IBAASL, May 2024. Time Zone 1, Paper 2. Question 1. There are two samples of rappers. For the Australian sample, the median is 80 mm and the interquartile range is 11 mm. For the spring sample, the information is shown on a box and whisker diagram. From the diagram, we can see that the median is 75. The lower quartile is 68 and upper quartile is 84. Therefore, the interquartile range is 16. Now, we compare the two samples. By looking at the medians, rappers in Australia have a higher median compared with 75 for Spain. When we compare the interquartile range, Australia has 11 and Spain has 16. This means the Australian data is less spread out, showing that the year lengths in Australia are more consistent. Question 2. A car is valued at $35,000 and its value decreased by 15% in the first year. So, at the end of the first year, the value of the car is 35,000 times 1 minus 15%. After the first year, the car continues to decrease by 11% every year. So, the value after 10 years is the value found in Part A, which is 29,750 multiplied by 1 minus 11% to the power of 9, since there are 9 more years after the first year. For Part C, after n complete years, the value of the car becomes less than 10% of its original value, and we want to find n. We set up the expression for the value after n years as 35,000 times 0.85 for the first year multiplied by 0.89 to the power of n minus 1, since there are n minus 1 more years after the first year. Then we set this to be less than 35,000 times 0.1. After solving the inequality, we find that n must be greater than 19.36, which means n equals 20. Question 3. We have a cone, and we want to find its radius. To do this, we look at this right-angled triangle. Tangent of 58 degrees equals 20 minus 1.8 divided by r plus 5. Solving this equation, we find r equals 6.37 meters. Next, to find the volume of the cone, we use the formula pi times r squared times the height divided by 3. We get 851 cubic meters. Question 4. X is normally distributed with a mean of 10 and a standard deviation of 2. We want to find the probability that X is more than 1.5 standard deviations above the mean. That means we are finding the probability that X is greater than 13. Using the calculator, we get 0.0668. Next, we are told that the probability of X being more than K standard deviations above the mean is 0.1. So, we first set up an equation based on this information. We change the inequality to be less than, which means the probability is 0.9. Using the inverse normal function on the calculator, we find that 10 plus 2k equals 12.56. Solving this equation gives k equals 1.28. Question 5. We are given a velocity function, and we want to find the smallest value of t at which the particle changes direction. This means we need to set the velocity equal to 0 and solve for t. Doing this, we get t equals 1.69. Next, we want to find the range of values of t for which the displacement is increasing. This happens when the velocity is positive. From the graph, we can see that this interval is from 1.69 to another point. Using the calculator, we find this point to be 6.12. Finally, we want to find the displacement relative to the original position when the time is 10. This is found by integrating the velocity function from 0 to 10. The result is negative 2.13. Question 6. There are two tests, A and B, and the student's score are shown in the table. Let X be the score on test A and Y be the score on test B. The regression line is Y equals 0.822x plus 18.4. To find the correlation coefficient R, we simply input the data into the calculator. Next, we use the regression line to estimate Y when x equals 10. Substituting x equals 10 into the equation, we get Y equals 27. However, this method is not appropriate for this estimation, because x equals 10 is much lower than any of the data values given in the table. Therefore, this is an extrapolation, which makes the result unreliable. Now, we are told that there is a data point where y equals 90, and we want to find x by substituting this value into the same regression equation. This is also not appropriate. Why? Because the regression line we have is y on x, meaning it predicts y from x. But in this case, we are trying to predict x from y. To do that correctly, we would first need to find the regression line of x on y, and then substitute y equals 90 into that equation. Doing so, we would get x equals 86. Question 7. We have an exponential function, f, and we want to find its inverse. To do this, we swap x with y, and then make y the subject of the equation. Now, the intersections of f and its inverse are points P and Q. Using the calculator, we find that for point P, both x and y are 0.26446, and for point Q, both x and y are 2.518. To find the distance between P and Q, we use the distance formula, which is the square root of the difference in x squared plus the difference in y squared. Since both values are the same, we can just multiply the difference by 2. Next, we reflect the function f across the x-axis and then move it up by 5 units. This gives us a new function g, which is negative f of x plus 5. The domain of g remains the same as the domain of f because there is no horizontal transformation, so it goes from 0 to 4. Finally, we want to solve f of x equals g of x. To do this, we bring all the terms with e to the same sign, then take the natural logarithm of both sides, and make x the subject to get the final expression. Question 8. We have a height function h of t, where t represents the number of hours after midnight. The graph shows h of t from 0 to 15. The lowest value of h is 0.5, and the highest value is 3.76. For part A, we know that the time between the first lowest point and the first highest point is 6 hours and 1 minutes, and we want to find m. First, we find the period of the function by looking at the constant that multiplies t inside the sine function. The period is just equal to 2 pi divided by that constant. This gives a period of 12.248 hours. The time between the first lowest and highest points is half of a period, which is 6.124 hours. The decimal part, 0.124 multiplied by 60, which runs to 7 minutes. For part B, we want to find the length of time between two consecutive highest points where the height is less than 1. We set h equal to 1 and solve the equation. The first two solutions are 3.569 and 6.707. So the answer is simply the difference between these two values. For part C, we want the rate of change of h when t equals 13. To find that, we take the derivative of h and substitute t equals 13 into it. Next, we have another function written as small letter h. The lowest value of h is 0.4, which occurs at 2 hours 41 minutes. And the highest value is 2.74, which occurs at 9 hours 2 minutes. We want to find the parameters a, b, c, and d in the expression of h. The value of a is the amplitude, which is the highest value minus the lowest value divided by 2. To find b, we need the period. The time difference between the lowest and highest points give half of the period. We convert that time difference into hours, then multiply by 2 to get the full period. The value of b is just 2 pi divided by the period. The value of d is the mid-level of the function, which is the average of the highest and lowest values. The value of c is the horizontal shift, which represents the time of the mid-level point of the sine function. To find this, we take the average of the times of the lowest and highest points. Finally, we want to find the capital letter T, which represents the time when the two functions are equal. Using the calculator, we find that t equals 4.16. Question 9. We have a triangle, and we want to find the two possible values of angle OAB. Since we don't have angle OAB and its opposite side, we first apply the sine rule to find angle ABO. By setting up the equation and solving, we find the two possible values for angle ABO, 69.875 degrees and 110.25 degrees. Then, using 180 degrees minus these two angles of ABO and also subtracting angle AOB, which is 28 degrees, we get the two possible values of angle OAB. Next, using these two possible angles, we apply the formula 1/2 times 25 times 50 times sine of the angle to find the two possible areas of the triangle. Now, we draw a line CD that divides the triangle into a smaller triangle OCD with area of 60. Let X be OC and Y be OD. We are asked to show the given expression. To start, we apply the cosine rule to this smaller triangle to form the first equation. Then, by considering the area of this triangle, we get the second equation. Next, we make xy cosine 28 the subject from the first equation and xy sine 28 the subject from the second equation. Dividing the two equations gives tangent 28 in terms of x and y. By rearranging, we can obtain the designed expression. Finally, we need to find the two possible values for OC, which is x. To do this, we make y the subject from the second equation and substitute it back into the expression we derived in part B. This gives us a single equation in terms of x only. Using the calculator, we can solve the equation to find the two possible values of x.